Alright, welcome again everybody to my channel where learning is fun. Today I bring to you another interesting topic which I call the Vigenere Cipher. Like we know, Vigenere Cipher is a traditional cipher, one of the traditional cipher actually, and it's very interesting and very cool. But before I go on, I'd like to appreciate those of you who have stayed with me on this channel, and I want to enjoin you to please drop a comment on this channel, on this video, share this video with others. More importantly, subscribe if you are here for the first time. I have a video about Cipher cipher which is displaying on your screen right now. If you have not seen that video, please click on the screen right now that is displaying right now and watch. Vigenere Cipher is another interesting one. Let's go. So, suppose that we have this gibberish. I don't know what it means actually, and I'm actually hoping that some of you will be able to figure it out after watching the process of Vigenere Cipher. So we have to look at the encryption process. There are some things you need to do when you want to encrypt a plain text using Vigenere Cipher. So one of the first things you need to do is to choose a secret key. You know, we have always mentioned it that encrypting, or the process of encryption, requires an encryption algorithm with an encryption key. The key is usually kept secret, and the strength of the encryption process, or let me say the crypto system, depends on the strength of the key and of course the strength of the algorithm. So we need to choose a secret key as one of the first things we need to do. The second thing we need to do after choosing a key is, in Vigenere Cipher system, is to convert the secret key into a numerical key. Normally the secret key is usually a word, and then we convert that word into a numerical value. I will show you how that is done in a minute. The third thing we need to do in the process is to arrange the plain text, that means the text you want to encrypt, into a table without spaces. Note that there should be no spaces in between words. We will see that process very soon. And the fourth thing after arranging them is to now arrange the numerical key. You know, we have converted a secret key, a word, into a numerical key, and then we will now arrange that numerical key under the plain text in the table. We'll arrange it under the table and we will repeat it until we get to the end of the table. So having done that, after doing that, the next thing we need to do is to begin encryption. Now this is the algorithm. To encrypt a plain text into a cipher text, you need to shift the plain text according to the numerical value, key value under it to obtain a cipher text. So it's a shift process, it's a shift cipher actually. So we look at the numerical key under the plain text, each alphabet of the plain text, and shift our plain text the number of times dictated by the numerical value under it. Yes. Now quickly note something here is that when encrypting, we shift to the right, but when decrypting we shift to the left. And that is why we say the last thing we need to do is to reverse the process in order to obtain a plain text. Is to reverse the process. That means the shifting. You reverse the shifting. When you shift to the right, you encrypt. When you shift to the left, you decrypt. Yes, so when you have something like this gibberish, this ciphertext, what you need to do in order to obtain your plain text is to shift to the left, and you will obtain the plain text. Alright, so that is the process for ciphertext. I quickly run over it once again. Choose a secret key, usually a word. Choose a secret key, and the secret key must be known to both the sender and the receiver, and it must be kept secret. That's why we call it a secret key. So because they both know it, they both can convert it, the secret key, into numerical value. I will show you how that is being done in a minute. Arrange the plain text with no spaces, emphasis on no spaces, in a table, and then arrange your numerical key under the plain text, repeating until end. Shift your plain text according to the numerical key value under it in order to obtain your ciphertext, and then you reverse the process in order to obtain a plain text. Now come with me, look at this ciphertext here. All of this process have been applied up to this number 5 in order to obtain this. So in order for us to obtain this, we need to apply this in reverse order. We need to apply all of this, and then we reverse this number 5, the shifting. That is, we need to shift backwards in order to obtain our plain text. Okay, so we will go for an example. We'll go for an example right about now. So, and the example is, we shall decrypt the ciphertext, this, into a plain text and see what we obtain. So come with me as we do that. At the end of the video, I will expect us all to come back and decrypt this on our own. Come back and decrypt this on our own. Then you drop whatever you obtain as a comment in the comment section down below. Thank you. Come with me as we do the encryption or decryption. Okay, as an example, we shall decrypt the ciphertext, this, into a plain text. Note this key, the secret key, is equal to COVID. That is the secret key, and I have satisfied this number one requirement to choose a secret key. So I have chosen COVID has been chosen as the secret key that was used to encrypt this. So the next thing is to convert my secret key into a numerical value. And how do I do that? I have this nice looking numerical table. So I will use this table to convert COVID into its numerical value, and then I will arrange it into this encryption table where I'm going to obtain my plain text. And let's see how it's done. So I have COVID, C O V I D, and C according to this numerical value will be equals to 3. O will be equal to 15. V will be equals to 22. I will be equals to 9, and D will be equal to 4. So my numerical key is actually 3, 15, 22, 9, 4. It's as simple as that. So I quickly arrange that into my numerical table, my encryption table, and we begin encrypting, or rather decrypting. So I have 3, 15, 22, 9, 4. I repeat it: 3, 15, 22, 9, 4. Now I still have more spaces on the table, on the encryption table, so I still repeat it again: 3, 15, 22, 9, 4. I still have 2 more spaces, so I just repeat it again: 3, 15. So I've gotten to the end of my numerical table, my encryption table, and I will stop at that point. Now the next thing for me to do is to arrange my ciphertext that I intend to decrypt into the encryption table. So I have F D N X R D X O J T D C Z N Q L R. So having done that, I can begin my decryption. Notice that I did not put any space in between the words. I did not put any space in between the words. So the encryption process, like I said, this is decryption process actually, so I have to count backwards. I have to shift backwards, and I'm still going to be using my value table here. So if I want to decrypt the letter F, okay, let me do it this way. Let me say F D N X R D X O J T D C Z N Q L R. Sorry, this is R. Then I look at letter F on my value table. I look at letter F and I have 3 on that. That means I have to shift it backward 3 times. 1, 2, 3. And then I have letter C. So F becomes C. Then the next thing I go for letter D, and I have to shift it backwards 15 times. Here is D, shift backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So letter D becomes O. Then I go for N, and I have to shift N backwards 22 times. I begin from N here, so I shift backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And letter N becomes R. think it's making a little sense here. X, I have to shift X backward. The numerical value under X is 9, so I have to shift X backwards 9 times. So I have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. O. So X becomes O. Your guess is as good as mine. We're getting somewhere. Letter R means I have to shift R backwards 4 times. R, 1, 2, 3, 4, and it becomes N. Wow, it's coming out nicely. It's coming out nicely. And then letter D, I have to shift D backwards 3 times. If I start with D, 1, 2, 3. Oh wow, and letter D becomes A. Wow, so I have the word corona. It's interesting. So let's go forward. X becomes the next X. I have to shift it backward 15 times. X 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it becomes I. Then O, have to shift backwards 22 times. And if you shift that backwards 22 times, O, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I have letter S. Letter S. And if I shift letter J backwards, according to this corresponding numeric value 9 times, I will obtain 1, 2, 3, 4, 5, 6, 7, 8, 9. A. Letter T now. Let's go for T. T, I have to shift backward 4 times. And then I have letter T. 1, 2, 3, 4. P. And D, if I shift D backwards 3 times, I obtain A. C. If I shift C backward 15 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I obtain N. And if I shift Z backward 22 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I obtain the letter D. If I shift N backwards 9 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, I obtain the letter E. And I think we already know what we are trying to achieve. Q. If I shift Q backwards 4 times, I'm going to obtain letter M. If I shift L backwards 3 times, I'm going to achieve letter I. And if I shift R backwards 15 times, I'm going to achieve the letter C. So we have the word corona is a pandemic. Corona is a pandemic. So this ciphertext here actually translates into corona is a pandemic. So that is the process of Vigenere Cipher. It's as simple as that. Don't forget, This again is the ciphertext I want you to decrypt using the same process and obtain. Let's see what plain text you will obtain. Thank you very much. I'll be expecting your results in the comment section below. Please, if you are new on this channel, once again, subscribe, give the video a thumbs up, share and drop a comment. God bless you. Thank you very much.